Assalamualaikum and hello everyone. Before we begin our presentation, have you ever wondered what coffee architecture is, its purpose, and how the interaction cycle works? Next, we will provide an overview of computer architecture to help understand how the processor interacts with other system components. After that, we will explain the interaction cycle in the coffee architecture, focusing on how instructions are fetched, decoded, executed, and stored. Finally, we will conclude the video with a brief summary of the key points in these classes. Let's get started! Intel Coffee Lake is a microarchitecture developed by Intel and introduced with the 8th generation Intel Core processors. It is based on the x86-64 CSC architecture and is manufactured using Intel 14nm++ process, which provide the higher clock speed and better power efficiency. Coffee Lake represents a major improvement over earlier generation like Skylake and Kaby Lake, especially by increasing the number of cores. For example, Core i5 and Core i7 processor move from quad-core to hexacore design, significantly boosting performance in the mainstream system. The main goal of Coffee Lake is to improve overall performance, multitasking, and efficiency. It is well suited for demanding tasks such as gaming, video editing, programming, and 3D rendering. In terms of specification, Coffee Lake supports up to 6 core and 12-thread larger cache size, DDR4 memory up to 2666 MHz, higher turbo frequency, and improved integrated graphics, resulting in faster and more responsive computing. Computer architecture explains how the main components of a computer system are organized and how they work together. So in this project, we focus on the Intel Coffee Lake architecture. Coffee Lake improves performance, efficiency, and multitasking by using components such as the CPU, registers, clock, system bus, and cache system. Understanding these components help us to know how the processor achieves fast and reliable performance. So, the CPU is actually the brain of the Coffee Lake processor. It is the multi-core processor, which means it can run multiple tasks at the same time. Coffee Lake uses a superscalar design and out-of-order execution, allowing instructions to be processed efficiently without waiting unnecessarily. And some models also support hyper-threading, which improves multitasking. Inside the CPU, components like the control unit, ALU, and FPU work together to perform calculations and control operations.
The next component for computer architecture of Intel Coffee Lake is clock. The clock controls the timing of all the operations in the processor. Coffee Lake processors start with a pace clock and multiply it to reach high speeds often above 3 GHz. With Intel Turbo Boost technology, the clock speed can increase temporarily when more performance is needed. This helps the processor to balance speed, power consumption, and system stability. Next is system bus. Instead of using the old front-side bus, Coffee Lake uses modern interconnections. The CPU communicates with the chipset using Intel DMI 3.0, which is faster and has lower latency compared to older bus designs. Other components like graphic cards, network, and storage device connect to CPU using the PCI Express. The system bus includes the data bus, address bus, and control bus, which allow all the components to communicate properly. Lastly, the cache system. The cache system in the Intel Coffee Lake processors help to reduce the memory access time. Each CPU core has a very fast L1 cache, which is divided into separate instructions and supported by a larger L2 cache. All cores share the L3 cache, which is improved data sharing and reduce the access to the main memory. This multi-level cache hierarchy greatly improves overall system performance, especially for multi-core processing.
Next is instruction cycle. What is instruction cycle? In instruction cycle is a step-by-step for CPU to process data through the fetch, decode, and execute cycle. At the first stage is fetch. The program counter holds the memory address for the next instruction, which is fetches from RAM into the CPU instruction register. Decode. Control unit determine what operation to perform and which data are needed to make a result for the instruction data. Execution is the stage that the arithmetic logic unit perform the actual operation on the data. At this stage, CPU control unit sends signal to the relevant functional unit, primarily the arithmetic logic unit, to perform the required action to the data. The last stage is store. The result is written back to the register or memory location, and the PC is updated to point to the next instruction and resetting the cycle.
To conclude, computer architecture explains how all the main parts of computer works together. The Coffee Lake CPU is powerful because it has multiple cores, allowing it to handle many tasks at the same time. Registers store small but important data, helping the processor work faster, while the cache and system bus move data efficiently and reduce the waiting time. The CPU follows the fetch, decode, execute cycle, where the program counter selects the next instruction and the control unit manages the operations. Overall, Coffee Lake Core i7 is designed for modern high-performance computing. Thank you for watching.